Metadirectors are groups that can be added to benzene rings that will cause it to react in the meta position. In this example, nitrobenzene is further nitrated. The results are 6% in the ortho position, 93% in the meta position, and 1% in the para position. The reason that this happens are for the same reasons that ortho and para directors react the way they do. But in metadirectors, it has the same reasonings, but the opposite happens. We'll have a look at the resonance structures of the sigma complex to explain why this happens. The first one is ortho, second para, last one meta. In ortho and para directors, the group that was added was an electron donator. It donated electron density. In metadirectors, they're electron withdrawing. And we'll see why that difference causes something to be ortho and para directing as opposed to metadirecting. So here is a sigma complex electrophile reacts. This one, it will be in the ortho position here. So looking at the positioning of the carbocation, here's the first one, here's the second one, here's the third one. And what causes this to be selected against is that in electron withdrawing groups, they tend to have a partial positive charge on the atom that's doing the bonding. So in this example up here, we add a nitronium ion. So like this. So this would have an effective positive charge on the nitrogen. Like charges repel each other. So if the carbocation were to be on here, this would be an unfavorable position for it. And it's the same thing in the para position. We look at the carbocation and distribute it to the different carbons that are still sp2 hybridized. Again, we'll have a situation where it's on a carbon that's close to something else that has a partial positive charge, where if it reacted in the meta position over here, this doesn't happen. It's not on this carbon. In the other case, where there was para and ortho, we wanted this cation to be on the carbon near the electron donator because it donated electron density and gave a little additional stability to it. But in this case, since it is something that is likely to be positive, since it's a strong electrophile, we don't want that carbocation to be near it, which is why it reacts so strongly in the meta position as opposed to the ortho and para positions.